Hello, hello, hello. We are back. Mm. So last stream we have covered a lot of topics. We went and flight through it. So we are not going too deep into it, considering that we know all of these topics and we have already worked on it and we pretty much know most of the syntax that is mentioned here. So we are not going too deep into it and we went through SQL database, RDBMS, data types in SQL. Um, there should be types of SQL queries. It is types of SQL commands. Therein we have DDL, DML, DCL, TCL, and DQL commands. In DDL we have create, alter, drop, and truncate. DML we have insert, update, and delete. DQL we have select. DCL we have grant and revoke. TCL we have commit, rollback, save point, and create transaction, start transaction. I could say, let's see the, it's begin transaction. Okay, cool. I'm sorry for the breathing noises. We also discussed about the acid properties, atomicity, consistency, isolation, and durability. Atomicity is everything gets committed or nothing gets committed in a transaction. Consistency is the data is consistent and in a while state in the database, and all of the constraints and data types are properly followed in the transaction. Isolation is if multiple transactions are performed on a single table, they don't affect each other. So the second transaction will wait for the first transaction to be completed, and only then and there the second transaction will take place. Durability is the data is saved permanently. Once the data is committed into the transaction, that is the database, it is saved permanently in the database. Normalization, we will look at it later actually. It's a bit hard to explain, I would say. Let's continue with it. I have my chai here. Mom? Wait, we don't have milk in our tea. शामध्ये दूध नहीं है. ओके ठीक है. तू म्हटलं होतं क्या आहे. Okay, I'm sorry. Let's continue. We discuss join. Inner join is common. Common records from both the tables. Left join is all records from the left table and common records from the right table. Right join is opposite of that. Full auto join is all records from both the tables. Wherever there are wherever the data doesn't match, it will return null as the value. Cross join is a Cartesian product, so cross join will be if one table has 3 rows and another table has 3 rows, so the result will have 3 multiplied by 3 equals to 9 rows in the result set. Self join is a join in which a table is joined with itself to return data. Let's continue. Correlated subquery we know. Common table expressions we discussed. It is a temporary table in the confinement of your current query. Views. So we discuss viewed. View is a SQL saved SQL query. It does not store physical data. It just stores the query, and every time the view is executed, the queries inside the view are executed. Indexes. Indexes are a optimization. Indexes are an optimization structure in SQL which are used to retrieve data faster in the database. So we have cluster index, non-cluster index, composite, unique index, and full text index. We don't deal with this, forget about it. Cluster index has sorted data, non-cluster index doesn't have sorted data, it directly points to the location of the data you're looking for. Consumes less space, consumes more space. Has composite index has multiple columns as the index. Unique index has only unique values in the index indexed columns. All right, continue with it. So without an index, the database will scan every row, which is very slow. With an index, a database will directly go to the matching row. We discussed all this. Clustered and non-clustered index. The differences. Now, now we are at functions. We stopped here in the last stream, so functions are a function in SQL is a built-in operation that takes input, performs tasks, and returns a value. So there are different types of functions. As we can see here, we have aggregate functions like count, max, min, sum, etc. String functions like upper, lower, length, substring, left, right. Okay. Date functions like now, date add, date diff. Scalar functions which return only a single value in the result set. So why do you use functions? Functions are used to transform data, perform calculations, extract and format values, manipulate strings, and work with dates. Most functions work on the row individually. So here is an example. So you can uppercase this string, so the output will be uppercase. Very simple. There are five major categories of functions. So scalar functions returns only one value, aggregate functions return one value for a group, String functions, date and time, math functions, and system functions. Scalar functions include upper, lower, len or length, trim, substring, round, convert, and cast. Aggregate functions include count, sum, average, minimum, maximum, and aggregate functions are aggregated using the group by clause. So for each group we'll get a aggregate value. You can also do an alias like this: avg salary. So an alias is a name given to a particular schema in a database. Object object in a database like table view or a column. We also have string functions upper, lower. It will convert to uppercase, it will convert to lowercase. Length will give you the length of the string. Concat will concatenate data. Substring will give you a part of the data based on the index of the characters in the string. Trim will trim the data from both sides. Ltrim will trim the data from left side. Rtrim will trim the data from the right side. So trimming is basically removing white spaces or any other characters from both the sides of the string. So you can also replace. Here you can see an example. So the string is India is great. We are replacing great with beautiful. So the result will be India is beautiful. We also have date and time functions. So get date or now to get the current date. Now is used in MySQL and PostgreSQL, and get date is used in SQL Server. We have date add to add certain days to a date, date difference between two dates, extract year, month, and day from a date. So year will give you the day, year, month will give you the month, day will give you the day of the month. We also have math functions. So round to two decimal values. So it is 123.456. So it will give 123.46 because 5 is larger number, so it will round to 6. So 46. Ceiling and floor, absolute value will give an absolute value. You can see this is negative, it will give an absolute value as 50. 2 to the power 3 is 8. You can see conversion functions. We also have conversion functions. So as a business analyst that I'm working for, I use this. So cast value as data type. You can do this. You can also do date time. You can insert a date time value here and you can cast it to date time or any other data type as such. Convert works in similar way. We also have system functions. We rarely use it, and Most of the interviews don't even ask about it, so we will not be looking at system functions. Let's get some system functions on ChatGPT and I'll put it here. Let's see what ChatGPT can give us. I don't know what's happening with ChatGPT. Let's not add any system functions in this. This is good. Let's continue. Where were we? Functions, system functions, window functions. Let's get some data about window functions in SQL. I'll just add summary of system functions right here. You can go over it if you want, it's not required. It is generating. My lip is a bit torn. So by recording this, I'm also working on my communication skills so that it's easier for me to talk to someone on a computer when I'm in an interview. So even I'm preparing for my job interviews these days. So let's work on it together. Even though no one's watching, I'm still recording this. Hope this helps anyone that's working on it. Let's see. Window functions. Get some content. Let's add some window function content here. Yeah. What are window functions? Window functions perform calculation across a set of rows related to the current row without collapsing them into a single row. Unlike group by, it's a bit hard to explain when we are just trying to explain it in words. So let's just get into some examples and we can look at it. So some of the things you can do with window functions are written here. So we can do running totals, ranking, moving averages, percentiles, comparing current row with the previous row, and finding top n per category. So the syntax is function name over in brackets partition by column, order by column, and this is optional, that is rows between. Even this is optional, but you can do this. Partition by is also optional. I think you have to do order by. It's not optional. So types of window functions. Types of window functions are aggregate, ranking, value functions, lead, lag, first value, last value, analytical functions like antile, cumulative distribution, and percent rank. Aggregate window functions, same as normal aggregate functions, but they do not group rows. So if the table has 10 rows, it will return 10 rows. So sum, average, count, min, max examples we can see. Employee, sum of amount over partition by employee, so it is grouped by employee. You can see order by sale ID, so sum by sale ID as running total. So 100, 100 plus 200, 300, 300 plus 150, 450, 150 plus 300. No, this for John it's done. You can see it for Mira now. 300 plus 100, 400. Like this you can do running total. Nice. Percentage of total sales. So sum of amount over nothing adds percent of total. Amount divided by sum is percent of total. We also have ranking window functions. So ranking window functions include row number, rank and dense rank. I have worked on this. So row number gives an ID for each row sorted by a particular column. Rank gives rank to the values in a column. So, and we also have dense rank. So if you can see, if we have values like 1 2 1 comma 2 comma 2 comma 4 comma 8, so it will rank it as 1 comma 2 comma 2 comma 4 comma 5. It will rank it like this, so it will skip 3. And same thing with dense rank, but what it will do is it will not skip any numbers, any ranks. So it will go like 1 comma 2 comma 2 comma 3 comma 4. So if you want to retrieve all the employees which have the second ranked salary, you can do it with this dense rank you won't usually use in your queries. It is for like when you have a race and you have to calculate the rank of the participants when there is a tie. So when there is a tie, both the candidates will have the same rank and the next will have the fourth, right? So it's like that. So top seller per region, you can calculate with row number. So order by sales descending, grouped by region. So in each region, total sales. Rank, as I explained, it's like that. So value window functions. This compare current row to the previous or next rows. So we have lead like first value and last value. Do we have any notification? Should I start playing game? Let's play a game. Geometry dash. Let's do 1. I'm both. Ah, ah. Let's not keep doing this. This is very addictive. I hope I'm looking good. Let me see OBS. Yes. My hair are bad. Why are my hair bad? Alright. I breathe a lot. I've seen. Now that I'm recording myself, I can see that I breathe a lot. I should stop doing that. It's not very appealing. Hmm. So lead like first value, last value. These I don't know. I have to practice this. Divide those into n equal groups. So this query will divide total spend into four equal groups. We'll go over this later. Top 10 products per category. You can say this is a subquery, a query within a query. Instead of doing this, you can use CTE to write a clean query. Customer retention. So previous order date by a customer. Calculate monthly running total. You'll use sum. Order by month. Moving average, you will do the same way. So for 7 days, you can use 6 preceding and current rows between. This is very important. You can mark it as important. Sudden drop in sales. So why are window functions important? So window functions are used in analytics, dashboards, reports, data engineering and ETL pipelines, very efficient compared to self joins. Simplifies complex calculations. Essential for interviews, Amazon, Microsoft and FANG. Used heavily in SQL Server, MySQL, PostgreSQL and Oracle. So for functions, the interview ready definition will be SQL functions are built-in operations that take input and return a single value or aggregated value. They help transform, calculate, format and analyze data efficiently. Stored procedures. So stored procedure is a reusable SQL code block. It's like a saved query, but it can take inputs. So a stored procedure is the pre-written block of SQL code stored inside the database that you can execute whenever needed. You can think of it as a function in programming but written in SQL. A stored procedure performs the task insert, update, read calculations by running multiple SQL statements together. Why is stored procedures? Stored procedures are used because they increase performance. SQL is compiled once and executed fast. They improve security. Users can be allowed to run a procedure without accessing tables directly. They reduce code duplication. Write SQL once, you reuse it everywhere. They simplify complex logic, multiple queries, loops, and conditions in one procedure. So, structure of stored procedure is mentioned here. So you can do create procedure, procedure name adds begin, begin and end. Between begin and end, you can write your SQL statements. In MySQL, you can set a delimiter, and the rest of the syntax is the same. Let's look at a simple example like mentioned here. So save it, and SQL Server we have create procedure get all employees as select star from employees. To call it, you can use the exec keyword and get all employees. You can also use store procedures with parameters. So create procedure, procedure name, and then add a parameter using the at the rate and the data type for the parameter, and as begin. Same thing here, they are doing department ID equals to either department ID, so you can just execute get employees by department. So you can just execute employees by department, and the ID is 5, so you will get the employees which have the department ID 5. You can use it to insert and delete data, like you can see here. Insert data using a store procedure. Real world example. So insert a new order into an e-commerce system. So create procedure, customer ID, amount, and product we have. So in values, he has added the parameters, and you can execute it. Unlike functions, you don't have to use parentheses. You can just use comma separated values instead. You can also update. You can also use if else statements in the stored procedure. If stock is greater than equal to quantity, then you can insert or else not enough stock. Store procedure is returning output parameters. I have no idea about this, so what is it doing? Total orders output. Hmm. You don't have to write a return. Here you didn't do anything right in the first one. This is insert. Hmm. So in that you are just returning one of the output parameters. Where was it? Uh, Here. It will return total orders. Customer ID 1001, total orders at the rate count of output. Store procedures with loops. Here's a while loop. And how did they do if else? If begin and else begin and end. Okay, cool. Here are some examples where you can use stored procedures. Web apps, insert users, login authentication, update profiles. In e-commerce, you can place orders, update stock, calculate totals. In banking, transfer funds, calculate interests, validate transactions. HR systems, you can add employees, update salary, run payroll. Data engineering, you have ETL processes inside databases like cleaning, transforming, inserting into staging tables. Pros and cons. So the advantages. The advantages are faster execution, secure, no direct table access, reusable, reliable, reduce network traffic. Disadvantages are harder to version control. Too much business logic in database is not ideal. Vendor lock-in. I don't know what vendor lock-in is. Let's skip that. So interview ready definition should be. A stored procedure is a pre-compiled set of SQL statements stored inside the database. It allows reuse, security, and faster execution and can take parameters to perform dynamic operations. So unlike a view, you can't use parameters. You can use parameters instead in a stored procedure. We also have user defined functions. I'm tired, bro. What is a UDF in SQL? A UDF in SQL is a user-defined function, is a custom function written by the user that returns a value based on output. It behaves like function in programming, like Java, etc. A UDF takes parameters, performs calculations or logic, and returns a single value or a table. Examples are get age. When do we use UDFs? To repeat the same calculation many times, need custom business logic, want reusable code, want consistent output across queries. UDFs is reduce code duplication and make SQL cleaner. Types of UDFs. Scalar UDFs returns a single value. Inline table valued UDFs returns a table. Multi-statement table valued functions returns a table with multiple steps. So scalar UDF returns a single value. So create function returns data type. Example will be returns int, calculate age, return int as begin, declare age, set age equals to dead def and return age end. So calculate age of date of birth as age. The tea was too sweet. I don't like it. That's why I usually don't drink tea. Real world example. Mask and email. So to mask and email returns. Interesting. So when there are stars added in the emails, you can do it using left and right and concatenate in a user defined function. Inline table value functions. So it will return a table. You can see it doesn't have any parameters. Oh, it usually doesn't have any parameters. It should have multiple parameters if possible. Did we see a function with multiple parameters here? Okay, this is fine. Triggers. Triggers and query optimization. We already looked over window functions. Let's go through triggers and we should be done then. So triggers. Triggers run automatically on insert, update or delete operations. What is a trigger? A trigger is a special type of stored program that automatically runs in response to a specific event on a table. A trigger fires automatically when a row is inserted, updated or deleted. You do not call a trigger manually, the database calls it when the event happens. It is called automatically on an insert, update or delete operation. We will see it in a while. So why do we have triggers? To automatically maintain logs, audit tables, enforce business rules, validate data before inserting, prevent invalid updates, maintain history or versioning, automate calculations. So main types of triggers are before insert, before update, after update, and before delete, after delete. Log deleted rows prevent deletion. Interesting. I never worked on triggers in development environment before, so I don't have much experience with this. So we'll have to go. So we'll have to go like this only. So real world example will be auditing employee salary changes. When salary is updated, save old and new salary in a log table. So create table, old salary, new salary, change. So you will create a table and you will insert data into the table after an update. So you can see here. So create trigger, trigger name after update on employees for each row. Begin if old salary is not equals to new salary, then insert into salary audit, that is the created table. We are inserting the values old salary, new salary and changed at. There is no from in this query. Interesting. Let me check how it works. Interesting. We don't need from in a trigger. So it will just refer to the updated row. Prevent deleting critical data. So if old is admin equals to 1, then signals equals state 45,000 set message admin accounts cannot be deleted. Interesting. E-commerce and HR systems. So real world example, automatically set created or updated timestamp. When deleting an employee, save the deleted record in a backup table. Prevent negative stock in e-commerce. So advantages of triggers will be automation, enforce business rules, maintain historical data, improve data integrity, and reduce repetitive code. Did it mention maintaining logs? So yeah, so maintaining logs is basically maintain historical data. So disadvantages of triggers will be harder to debug, hidden logic, may slow down large insert update operations, and complicate ETL operations. So interview ready definition will be a trigger is an automatic piece of SQL code that runs when a specific event occurs on a table like insert, update, or delete. It is used for auditing, validation, enforcing business rules, logging, and preventing invalid operations. So variables in SQL. So local variable, you declare them and set them, and variables are system variables like row count, error, identity, etc. So transactions. So let's get some info on transactions. Explain transactions in SQL. We are just doing simple chat GPT and copying data from chat GPT to here so that we have everything that we need here in this single document, everything that we need. It is generating. Let's wait for it to generate the data. Meanwhile, we'll look at the stream. After this, we will look at some study material that other people have created on the internet so that we can refer to that and see what everyone has done in those aspects. So we'll be going through SQL, we'll practice some SQL queries and problems on maybe lead code and some other websites, and then we will move on to revising some Python, and then we will move on to data engineering concepts such as Linux, cloud. In cloud, we will do Azure, and then we will do Spark, and then we will do Azure on Databricks. We will try to get the associate data engineer certification for Databricks with Azure so that we have something to put onto our resume and show our skills. We should also be able to build some data pipelines, complex data pipelines using ETL and ELT on either Databricks or simple Apache Spark environments. So that's what we are going to do. I think it has generated transactions, some content for transactions. Hmm. So in transactions we have begin transaction, and then we have some operations like update. Here he has used a logic for error. So if there is an error, rollback or else commit. Let's see what we have. So what is a transaction? A transaction is a group of SQL statements that is executed as a single unit of work. Either all statements succeed or none of them do. This ensures data consistency, especially when multiple table updates happen together. Asset properties. Asset properties we already discussed. We have automaticity, consistency, isolation, and durability. All operations succeed or all fail. No partial update is done. So consistency, as the database moves from one valid state to another valid state. So all the constraints in the database and the data types are consistent in the operations, in the transactions, that is. So it is always consistent in, it is always in a valid, that is consistent state. Isolation is each transactions works separately. Only one transaction is operational on a single table at a time. So when one operation is being performed by user 1 and user 2 wants to do some operation on the table, the user 2 will go into deadlock until the first operation is completed, and then and only then the second operation will take place. Durability, we have once committed, the data survives crashes and system failures, and whichever transaction is committed into the database, it is permanent. So in case of any failures, the data is either not saved or completely saved. There is no in between. It will not stop in between an insert operation or a delete operation. Where transactions needed, money might be detected from one account but not added to another. Orders may be created but inventory not updated. Partial updates may corrupt data. Transactions protect the integrity of the database. So we have the syntax, begin transaction, SQL statements, commit or rollback. Here are some examples. Hmm. Let's move summary to the next page and we should be good. A transaction, a group of sequestration executed as one unit ensures as its properties commit, saves changes, rollback, undoes all changes used in banking, orders, inventory, booking, payroll, etc. Prevents partial updates and data corruption. That's it. I think we have it. Window functions we already discussed. I don't know why it is here. So for query optimization, this is very important. Query optimization, you can use indexes, avoid select star. You don't retrieve all columns from the table. Use exists over in. Instead of in, you can use exists keyword. Avoid functions in where. Don't use any functions in where. Use proper data types. Reduce subqueries using CTEs. And partition large tables. These are query optimization techniques used in SQL. So that is it. I think we have covered most of the topics that are important in SQL. We left normalization though. Should we go through it? Do we have some time? Okay, simple. We'll do normalization. Where is it? Normalization. So normalization is used to reduce redundancy in the tables. So first enough form has atomic values, no repeating groups. So if there is an employee table which has a phone column, so if the phone columns has comma separated values with the phone numbers of the employees, so we don't want that. So to convert it into first enough form, we will separate the phone numbers into multiple rows so that we have only single values in all the cells in the table. That's it. That is the first normal form. We'll see some examples in some time. So second normal form. So the data needs to be in the first normal form and then there is no partial dependency applies to composite primary key. So when there is a composite primary key, that is when the rest of the data depends on multiple columns that are in the primary key, then there should be no partial dependency of a particular column in the table. So that can be separated into a separate table. So if we have like a store table which has store ID, store name, order ID, order name, order ID, product, and order amount. So orders can be a separate table in this. And third normal form is there is no transitive dependency. So transitive dependency is like if A is dependent on B, A column is dependent on B column and B column is dependent on C column, then C column is by default dependent on the A column, that is transitive dependency. So this can be simplified further by distributing, by splitting the data into multiple tables. Voice code normal form, stronger version of third NF. So normal the voice code we will see in some time. I don't remember how voice code works. Yeah. It doesn't deal with composite primary key. So in voice code normal form, only one column in the table should be unique for the rest of the columns in the table. So all the rest of the columns in the table depend only on one column. That is the that is usually the ID in the table. So why do we normalize? We remove duplicate data, ensure consistency, reduce storage, improve insert, update, delete of performance, and make relationships clear. First normal form, no repeating groups. As I said, if there are multiple phone numbers, we don't want that multi-valued columns. So there should be no multiple values. We can split it into multiple rows. Each cell contains only single value, as I said, and each record is unique. Each record should be unique. So as you can see, there are multiple numbers in the phone numbers column. We can split it into multiple rows like this. That's the first normal form. And the second normal form, if it is already in the first normal form, we can have student ID, course ID, and course name. We can split it into student course and course. So student ID is dependent on course ID is dependent on student ID and course name is dependent on course ID. So this is the primary key and this is dependent on this. So this can be separated because it does not depend on student ID. This is partial dependency you can see here. So that is it. It is split into student course and course table. You can see here third normal form. So there is no transitive dependency. So employee ID, employee name, department ID, department name. So employee name is dependent on employee ID and department is dependent on department name. So this can be separated. Yeah, that's it. That's the third normal form and voice code normal form. Voice code, did we do voice code? Yeah, we third enough. Okay, that's it. So that's normalization. We are good, so we covered most of the topics that can be asked in an interview. This does not cover the query part of the actual query problem parts of the interviews. It only covers the basics and what topics are asked in interviews. So if you want to practice, you should go and find some problems and solve it into SQL. Just pick any SQL database like SQL Server, MySQL, download MySQL Workbench or SQL Server Management Studio and start practicing everything that we learnt. Here you can see these are operators, so in or and these are operators in SQL. You can also look at that is the same thing that we use in Python or any other programming language, so not much to discuss there. You can use those in the where clause. I don't think that's mentioned in this document, so I remembered it. Alright, that's it. I hope we are recording this. That's it. We'll look at some other topics later and we'll practice some problems in SQL on maybe Lead Code or any other website. It's 2 p.m. so it's time for my work, so I will not be able to stream for any longer. I might have some work and I'll have to attend some meetings. Thank you. This is it. I hope you are doing well and keep learning, keep getting better, and we are good to go. Thank you. Bye bye.